Class, we started solving the review problem, and we reached question number 10 in the review problem. Just to remind you, show you the problem. Question number 10. A person walks fast at a constant speed of 8 meters per second along a straight line from point A to point B, and then back along the line from B to A at constant speed of 3 meters per second. Sketch the path of the trip and answer the following. The first part, what is her average speed over the entire trip? Second part, what is her average velocity over the entire trip? All right? So if you remember, we already did the first part, part A. What is the average speed for the entire trip? And we said she goes and come back, 2 Ds, total distance, and total time, time to go, time to come back. And then we used the definitions of S1 as D1 over T1, S2 D over T2, and then we got rid of D and we found the average speed for the entire motion. Now part B says what is the average velocity for the entire trip? Average velocity, what do you need? Displacement and time. Where did you start? At x1. Where do you finish? A. What is delta x?
0.
So what's the average velocity? 0. So this is the easy part. Okay? So this is question number 10. And now you are able to do question number 11, the one after on the sheet. So I leave it to you. You read it in your own spare time. And it's much easier than this one, question 11. Now we go to another group of questions now on the review problems. If you look at question 12, page number 2, question 12, and then question 13, 14, 15, 16, 17. Those are all about graphs. Yeah? About graphs. You have graphs of xt or vt or at. So what I'll do, I'll choose a sample. So let's say we look at question 16. What is 16? Yeah, question 16. Look at question 16, 1-6. Oh, actually, sorry. Let's look at question 13 first. Page 3. Page number 3. Page number 3. Question 13. I read the question. The graph below shows the velocity of a particle moving along the x-axis as a function of time. So we have velocity time graph. If x, if the position x equal 2 meters at t equal 1 second, what is the position of the particle at t equal 6 seconds? All right? So let's do this question now. I'll just do a sketch here for you for the graph. So this is a question 13. And the velocity time graph looks like this. Here the intercept is 2. The lowest here 3. And here you have 6. And this is 0. This is 4. And the lowest here, it's around -2. And this is a velocity time graph. Question number 13. Now, what's the question? Find x. Position where? At time 6. So I want here x at 6. If you have a VT graph, How do you answer questions related to position, displacement, distance? Area under? Velocity time graph gives you area under the graph. So, but area means you have a starting area, finishing area, yeah? Here, this is like the end, yes? I need the beginning. Now, the beginning, it's in the question. The question says, if x equal 2 meters at 1 second, yeah? So where is 1 second? 1 second is here, which means this point. And if you look on the scale, you find this point is equivalent to, but be careful, this is not the position. This is the velocity, but it just happens the same value. The position and the velocity are the same, yeah? Just by coincidence. So, where is my starting area then? I have to start at 1. Which means you ignore this area. At 1, what do you know? X1 is 2 meters. X6, unknown. And this is velocity time graph. So how I find the position? The area under the graph from here, from 1 to 6. So how many areas we have? Area 1 and area 2. Okay, don't forget, this is an XT graph. A VT graph. So in a VT graph, the change in position, displacement, equal area. Change in position, final is x6. Initial at x1. Equal area. What is my area here? Area 1 plus area 2. Shall I use absolute value for the areas? No. Because I'm talking about positions, displacement, they have signs. You don't. Area 1. It's a triangle, yeah? Half. What's the base? 1. The height? 2. 1, 2. Plus. Area 2 is a triangle as well, yeah? Half. What's the base from 2 to 6? 4. And the height is the lowest here, yeah? Minus 2. 2 with 2. So this will be 2 minus 4. Don't forget, there is a minus here. 1 minus 4. Minus 3. And x6 is unknown. But x1, given, yeah? 2. So x6 is 3 plus 2, 5 meters. This is the position at 5 plus. You got the idea? So if you have a VT graph, and the question is about position, displacement, distance, think of the area under the graph. Delta x equal area. This is what? No, this is okay.
Minus 3 plus 2. The last step. It's minus 3.
Oh, there's minus 3, yeah. Minus 3 plus 2, it's? Thank you, yeah, minus 1. Next. This was question 13. Let's go to question 16. 16. Question 16 in the review. A particle starts from rest at time 0. Particles start from rest at time 0. Its acceleration as a function of time is shown in the figure below. What is the speed at the end of the 6 seconds? What is the speed at the end of the 6 seconds? You can see there is a graph there. Okay, so now I'll put the sketch here for the graph. This is t, and this is acceleration. 4, 2, 0, 1, 2, 3, 4, 5, 6, 2, 4, minus 2. Okay, the graph here is acceleration time graph. And what's the question? What's the speed? Where? At t equal 6 seconds. When it says 6 seconds, it means here, yeah? So what do I want here at 6? Okay, change the question. What do I want? The velocity's value. See? Velocity value means speed. So here I want v6, but means x6, yeah? Now, if you have an acceleration time function, how do you find velocities or speeds? Area under the graph. What is the formula? The change in velocity, not speed, look. Change in velocity equal area. Now, it means I need a start and finish for my area. Of course, if I want the velocity here at 6, I have to know another velocity or speed, yeah? What is mentioned here? A particle starts from rest. At what time?
0.
So I know that V1 is 0 at t equal. So where is my starting area? Here. V1 is 0 at time 0. Which means I have to find the area from 0 to 6. I have two areas, area 1 and area 1 plus area 2. And this is V6 minus V1 or V0. Yeah, sorry. Say put 0 because it's times 0. V0. What is V0? V6 unknown. Now the areas. Positive area, negative area. 4 by 2 plus what? What's the width? By what? By minus 2. 8 minus 4 V6. So V6 equal 4 meter per second. Okay. Next question. If you look on the sheet, question 17. Now, question 17, the sheets I gave you, there's a small mistake there. The scale of the time has shifted, so put them back. But for the camera, it's okay. So what I want you to do is that, can you see the scale of the time? At each tick is 5, 10, 15. They shifted. Put them back. Okay, the last 3, they shifted. Put them at the corners, yeah? Because I expanded the graph. Anyway, let me read the question. Question 17. An object is moving along the x-axis, motion in one dimension. The graph shows its position, which means x, from starting point to as a function of time. X as a function of time. Position, time function. Various segments of the graphs are identified by part A, B, C, D. Segments. Part A. What is the average velocity of the object during the time interval from 0 to 30? We want the average velocity from 0 to 30 seconds. Second part, B. What is the average speed from 0 to 30? Part C, sketch this xt, change it to a velocity time, sketching. So change the xt function to a vt function, but sketching only, but keep the time scales the same. So let's see if we can do this one together. Yes.
I have a question here.
Yeah.
Yeah, he wants the speed, so it's going to be.
But because it's already positive, I didn't.
Yeah, but
Oh yeah, yes, definitely. Here you can just put here S6, V6, absolute value.
I mean, like we have to do like the area one absolute.
No, this is wrong.
Why?
Area equal what? That's a good question. She said, why I don't put absolute in each A?
It's not a,
First, not delta speed equal area. Delta velocity has a sign or not? So here it's not an absolute value, no. You're finding the change in velocity, and velocity has a sign. Then, once you find the velocity, you take the absolute value. Not from the beginning. This is not an VT graph, and you are asked to find the distance. You take the absolute value. No, this is different. No, this is always no absolute value in this formula. Delta V equal area. And you don't use absolute values for areas here. Because velocities, they have signs. Yes? I think we answered this question before. The areas here are not real areas. They are not length and width areas. What is the height here? Acceleration, yes? Acceleration could be positive, could be? So it's not a real height. It's not a real width or length, yeah? So it could be positive, could be negative. I'm not measuring area, length, and width as if you have length and width, no. The area here means something. What does it mean? Change in velocity, and change in velocity or velocity has a sign. So the area has a sign, sometimes positive, sometimes negative. So it's possible. Right. 17. A sketch for 17. This is time. Just be careful with 17. It happens before. If you look on the sketch, where is the 0, 0? In the middle, not at the lowest point. Okay, you have the scale at the lowest, but your 0 is in the middle, so positive, negative. Okay, be careful. So 0, 5, 10, 15, 20, 25, 30, and t second. And here I have 5, 10, negative 5, negative 10. This is part A. Look here, this corner. Part A, this is not at 10, not at 5, in the between. So in between means 7.5. Then straight up to 15. When you reach 15, you go down up to minus 10. Okay, so this is how it looks. And this is, what is it? Position, yeah? Position time function. Right, what is the first question? Find?
Average velocity from 0 to 30.
I want average velocity. So I want V average. From?
0
To where?
30 seconds. And the whole thing.
Okay. Now, average velocity. What is the formula, Rayam? What's the formula for average velocity? Average velocity. Not average speed. Yeah, delta x. Okay. So V average is delta x over. So if I want from 0 to 30, it means I need x at 0 and x at 30. What is x at 0? At 30. So what is delta x? Over 30, 0. Second part, what is that? We want the average speed. From where?
0 to 30.
Still, same question. What do you need for average speed? Distance over time. How much is the time? 30, yes? But the problem is in the distance. What is the distance moved from 0 to 30? How do we find distance? How? Is it the same as displacement? No, because you have to think if you have turning points or not. Do we have turning points? At what time?
5 and 15.
Between 5 and 15. Either you say 5 or 15 is better, yes? Because it's a plateau. So from 0, this is the first. And second. So I have 2 turning points. Now, from 0 to 15, did you turn? No. So distance and displacement? Equal in magnitude. So what's the distance moved from 0 to 15? 7.5. So the distance here, D, is D1 plus D2 plus D1 from 0 to, so 7.5. Now D2 from 7.5 to what? To minus 10. From here to there. Absolute value, how much is it? 17 point. Plus, you are here. What is it? And now you are here. So how much is this? D3, 10. Add them, it gives you the total, D. So how much is it?
35.
35. Over the time? 30, yeah? Now, the graph part. If you have an XT graph, how do you draw VT graph? You have to change. Think of the slopes, yeah? Now, is this a linear function or non-linear? So it's easy, yes? How many slopes you have?
3.
For each part, One. One slope, yes?
2.
Which is no slope here, 0.
3. 4.
And each part constant or variable?
Constant.
So when you draw the VT graph, your function is either straight or 0 or negative. Positive, 0, negative, positive, yeah? Let me show you what I mean by that. This is T. This is V. I'll put the same time scale. 0, 5, 10, 15, 20, 25, and 30. All right. From 0 to 5. How many velocities? Constant. How much is it? The slope. What's the slope of this line? 7.5 over? I don't know, but you calculate. Positive or negative? So it's here. Now you can give me the value. The value. 1.5, yeah? Positive. Now from 5 to 15. 0. It means when you reach here, suddenly what happens? Not gradually, suddenly. From 1.5 down to 0. And you stay at 0 for how long? 15. To 15. Here what? V equal 0. When you are at this corner, what happens now? How many slopes? Which means one velocity, constant. Positive or negative? Negative. Okay. Calculate it. You need 2 points, yeah? This is 1.2 or 3 points, yeah? Calculate the slope. But it's negative from 15 to 25. Minus 3.5, so look, sudden drop. And then from negative suddenly becomes what? Positive slope. One value, constant. What is it? Find the slope here. When you calculate it, it's positive. So you jump to a positive value and you stay constant. What is this value? 1, I think, yes? It's too high here. It's 1. That's it. Slope. What's the slope of this line? You need 2 points, yeah? Choose 2 points. Delta y over delta x. 1.5. Minus 3.5.
Till 20 seconds.
You shifted it to 20?
Yes.
Yeah, okay. Thank you. All right, so this is wrong, yeah. Okay. To 20, yeah. And then you jump up from 20 to 30. This is from 20 to 30. Right. What's next? Now we move to the free fall questions. Free fall. The last questions. Remember, for the free fall in the sheet I gave you, the solved one, I already solved 2 for you. Not in the review. I solved 2 questions in the handout. The handwritten one. The masterpiece. Remember the masterpiece? So you already have 2 solved. What are they? Question 20 and 21. I did them, yeah? But anyway, let's go through this part. If we go to question 18, you can see question 18, 19, 20, 21, 22 to the end, 23, they all about free fall. So 18, 19, 20, 21, 22, and 23. Now, let's look at 18. Question 18. Eighteen says, a ball is thrown upward with initial speed of 20 meters per second and then falls and is caught by the person who threw it. Part A, how high does the ball go? Part B, how fast is it going the instant before it caught? Part C, how long it is in the air. Okay? So let's see how we can solve this question. Free fall. Now, remember, in a free fall, you have three equations of motion, yeah? What are they? This is question 18. Yeah? We have V2, V1 minus GT, V2 square, V1 square minus 2G delta Y, and delta Y, V1T minus half GT square. Now, let's sketch the question. There is a ball. Which way is being thrown? Upward. So if this is the starting point, it's going this way, upward. When you throw something upward, it goes up to a maximum, and what? Stops, and then turns back, yeah? Now here, it depends on the question. It could finish at the same level or continue. In our question, same, because it goes and caught by the same person, back. So there is no motion under this point. Now, listen, the strategy is this in a free fall. Always number the major point with numbers 1, 2, 3, 4. Now, where is the starting point? Here. So I call this point number 1. And then see in the motion here, what are the other major points? This is the major point at maximum, yeah? Call it 2. This is the major point because at the same level, yeah? Point. And of course, if you have a point here, call it 4, 5. Doesn't matter. It doesn't have to be in the same sequence. Now, what is the first question? Find what? I want the height. Height, where you started here, yeah? Where is the maximum height when it reaches? So you want this one, h, yeah? Now, in a free fall equations, do we have heights or displacements? And displacement and height are not necessarily same. First, height is always positive. Displacement, sometimes positive, same time. Second, sometimes the height and displacement are the same. Sometimes now you talk about the displacement somewhere and the height somewhere else in the part. So it's not like you always think that delta y in the formula is the h you are looking for. You have to follow that. Now, I want h from where to where? Think of points. Okay, so it means in the equations, to translate it, I want delta y from 1 to 2. I want delta y from 1 to 2, which means you have to apply the equations between 1 and... Okay, so what you say, let's try. We say from point 1 to point 2. Okay? Then you decided now to do calculations between point 1 and point 2 only. No other points. Nothing. Right. Next, in these equations, you have 4 terms. Always 4 terms, yes? Initial velocity, final velocity, time, displacement, delta y. G is always known, yeah? 4 terms, yes? Out of these 4s, if you know any 2, you can solve. Find the rest. If you don't know 2 things, you can't. So now, between 1 and 2, what do you know? Do you know V1? Do you know V2? 0, yeah? It means you can calculate things. Now, if I choose equation number 1, this will help me to find something? Why not? If I put V1 and V2, G known, I find the time. Between 1 and? That's something I can find, but this is not the question I'm after. So just keep it aside. If I go to the second equation, V1 known? Yes. V2? Yes. G known? Yes. What I'll find? And this is what you're looking for? Okay, but let's go to 3 as well. Unknown. Unknown. You can't. 2 unknown. So those 2 are valid for you, between 1 and 2. But which one is better? This one, to answer it. So now rewrite the equation according to the points. V2 is still V2. V1 is still V1. Minus 2G. But delta Y, from where to where? From 1 to only. You can. But that's an extra step. Now, what is V1? What is V1 in the question? Read the question. It says, what's the sentence? Initial speed. Listen. Initial speed. These are speeds or velocities? What's the difference?
Direction.
Speed is the velocity without direction. Which means you have to decide the number 20 in the question. Shall we use it positive or negative? Point 1, look here. Which way is the velocity? So it's plus 20. So here we put 20 square. Final velocity, 0. Minus 2, 9.8. It gives you delta Y from 1 to 2. When you solve it, it gives you delta Y 1 to 2. How much is it? 20.4 meters. Okay, listen carefully here, please. What we found here?
Delta Y.
And remember, delta Y is not height. Shortest between 2 points. The shortest distance between 1 and 2 is? Is this delta Y same as the height between 1 and 2 or different? Okay, in this question, okay. Not always. So this is same as H. But absolute value, just in case this is negative. Part B. What is part B? Find what? How fast? How fast means what? Find the speed. But the equations gives you velocity. What's the problem? Find the velocity, and if it's negative, remove the negative. Which velocity I want?
The instant before it is caught.
Okay. Do you understand this one? What is the velocity the instant before it's caught? Remember, you threw the pen and back to your hand. How fast? At what point? At what point? 3. When it comes to your hand, what is the speed? This is the common mistake. The velocity at 3 is not 0. Just before it reaches your hand, not when it reaches your hand, after 2 seconds when it stopped. If you say the velocity is 0 when it comes to your hand, it means you don't feel the pain. When something goes up, stops, yes? Now, follow the speed. Increases, yes? Look here, Razal. Increases, increases, increases. When it reaches my hand. When it reaches my hand. Does it have velocity or not? You said increases. So how come suddenly it becomes a stop? It hits your hand with a velocity, then it stops. When we say velocity at 3, it means when it approaches 3. Not when it reaches 3 and then you stopped it by force. So I have a velocity here. Which way is the velocity here? Down. I want this V3. Okay? To find velocity, to find anything, what do you need? A strategy. Start and finish. Look, start and finish. Give me a start, give me a finish point. She said 2 to 3, yes? Let's follow what she says. Give me the equation which you want between 2 and 3. First, second, or who said 2 to 3? You? Okay, give me which equation will help me. Second one. She says second one, but applied between 2 and? So adjust it. What is the initial velocity? 0. No, adjust it to the numbers. V2. V3. From 2 to 3. I'll write it so you remember that. It means V3 square, V2 square minus 2 G delta Y from 2 to 3. Okay? Now give me the numbers. What is V2? 0. Minus 2, 9.8. What else do you know?
Minus 20.
Well done. But some of you, I think, you put already in your head here, what? 20 point? It's wrong. That's why I put the numbers. From 2, this is a start. This is Y initial for you, yes? When you reach a 3, which way is delta Y? So this height will be minus. Minus 20.4. If you don't put the minus, you know what happens? You'll have V3 square equal negative. And square never negative. Impossible. You can't have square something and it gives you negative. It means you did something wrong. You missed this minus. But now if you have minus, minus, plus becomes square, yeah? Now what's the value? 2 by this, it gives you V3.
399.
Final? 20? Good. Now, look here, look, all of you. Can you conclude something? What is V here now? Of course, you have to put a plus and minus. Whenever you take a root, plus and? How much is V3 now? Plus or minus 20. What is V1? Can you link?
Constant?
1 and 3, aren't they at the same level?
Yes.
So the speeds are? Not constant, equal. Anything you throw with the speed up, it comes back with the same, at the same level. So if I take this point here, look, this point, which way is the velocity? Up. There is a point here. Which way is the velocity? Down. But the speed here and the speed here, equal. That's why it's dangerous to fire during weddings, vertically. If you fire vertically, what's the speed of the bullet? On average, the speed of the bullet, around 700 meters per second. 700 meters per second. So the speed up, 700 meters, it goes up, slows down, stops, yes? Then what happens? The speed up, speed up, speed up, speed up. It comes back to the same level. Your head, same level. What's the speed when it hits your head?
700 meters.
It's like you shot yourself. Don't do this, just do this. You killed yourself. So it's dangerous. Yeah. Of course, this is an ideal situation because when you fire, there is an air resistance. But it slows down a little bit. It still is dangerous. So you have to fire at an angle. Okay? So now you should know that at the same level, you have the same speed without calculations. But be careful here. You have plus and? Which one do you take? No, minus. Going down. V3, at V3, down. So the answer here, V3 minus 20 meters per second. What is the last part? How long it's in the air? Which means, which time? T from point 1 to point 3. From point 1 to point 3. I'll finish in 5 minutes. If you don't know. I'll just finish this one. Okay? From 1 to 3. What's the time from 1 to? Which equation? This has time. This has time. Okay. First one? First one between 1 and 3. Look, I'll follow her. So V1 is okay, yes? V1. But V2 becomes what? V3 minus GT from 1 to? Okay. Do you know V1? Yes. 20 minus 9.8. T unknown, yeah? 1, 2. Do you know V3? Minus 20. You know it. You found it. Minus 40 with minus plus, yeah? So I'll have 40 over. And T is 4 point something. 8, I think. Yeah. Give me another strategy to answer this question. Give me another strategy. Same question. Find the time from 1 to 3. 1 to 2. Find the time from 1 to 2 multiplied by 2. Now, okay, which equation do you use? From 1 to 2. First or last? First. So V1 is okay? V2 is okay. So I say V2, V1 minus GT from 1 to 2. V1, 20. V2, 0. Minus 9.8 T. So what is T? 2 seconds. Half of that, yes? So T from 1 to 3 is equal T from 1 to 2 multiplied by 2, which is 4 seconds. I want someone to give me another strategy to find T. You did it that way. You did it this way. Give me another way. Come on. Did you use this equation? Does this equation has time? Okay. Okay. I want to apply this equation between 1 and 3. Delta y is what? No. Listen. I want to apply this equation from 1 to... Now, what is this delta y? From 1 to 3. So delta y from 1 to 3 equal, what is this? V1 T from 1 to 3 minus half G T square 1 to 3. Now let's substitute. How much is V1? 20. Yes? Time, you want the time. Half G, 4.9. T square, 1 to 3. What is delta y from 1 to 3? 0. This delta y is displacement. It's not the distance. You are at y1 and then back to y1. Initial and final. So what I put here? 0. You start, look, I know you're throwing it. This is initial y, y1. Where is y2? What's the difference between y1 and y2? It's like you went and back to the same point. Displacement is 0. So when you put the displacement 0, you mean you're doing calculation between 1 and 3. You've solved this quadratic, it gives you the same answer. 4.08 seconds. Okay? I think this is enough for... I finished the chapter, yeah. All what you have to do, practice. If you have any questions, you come back to me. Yes?
Just for the V for this, how fast is it going?
Just the velocity without a sign.
Speed?
Same.
يعني عادل ولا عمل؟
Yes, velocity or sign. Thank you.